I'm Ryan, and yeah, I sit on the data AI platform here at Character. Character's an LLM company. We train large language models and use them to you can talk to them. They're fun. They're fun to talk to. So kicking this off, as I said, I'm Ryan. Right now, the AI platform team is a few of us. It's me and a person called Katie Yoshida. And there's we do a lot of things. We're kind of part of an infrastructure team. We're kind of part of a training team. We're kind of part of a data team. We're responsible for all of the data pipelines, building tooling for our researchers to really easily make new data sets and load those data sets into training models. We're into our data catalog. We're into GPU services. We're into kind of a lot of things. We do a lot of different things. We kind of sit at the intersection of a whole bunch of teams. This is kind of what our stack looks like. We are a heavy Google shop, and we kind of love data lakes. So this is one of the reasons why we love Lance, because they have a file format. It sits in our data lakes. So we have everything in Google Cloud Storage. This primarily for us means Lance, Iceberg, and Hive. We extensively use Spark, as well as Trino, which is just sort of this SQL connector thing, and also Beam. On top of those things, sit dbt, which is this lovely project that I guess everyone uses now to kind of organize our data. And then on top of that, we've built tooling, as well as use Hex to explore data. As an example, we have a whole bunch of tooling that will launch you a Spark cluster, connect it in a PySpark notebook, and you can run interactively on 8,000 CPUs. We are kind of a very heavy self-host shop. The reason for this is because when you buy a GPU, when you buy an H100, you typically get a lot of CPUs along with it. And we don't really use those CPUs super heavily for training. So we love throwing everything in Kubernetes and co-locating everything. So that's kind of our high level thing. We think our kind of mission statement here is we really just want to be this bridge that builds tooling and helps people kind of get their data and we'll just stay out of their way. We don't want infra. We don't want these tools to be in people's ways. So really we want non-data people to have delightful, joyful tools, right? Cool. And at a very high level, we have this kind of flow chart where we have some data, we have some mining, we do some magic, we train a model, and ideally get some sort of state-of-the-art thing. This is obviously ludicrously simplified, but I'll kind of show a more in-depth pipeline of what this looks like. This is, I think, a very common kind of funnel. We initially have some raw data. This might be the pile. This might be the internet. This might be gigantic amounts of multimodal data. We use our favorite open source tools like Spark. I'm going to get to this in a second, but we have a bias that we came from the more data-y world rather than more machine learning-y world. So we love SQL. So you can imagine we have very raw data. We run gigantic Spark jobs on tens of thousands of processors that does things like transform it, does basic filtering on it. A great tool, if you're building LLMs, is LLMs. So things we can do, I'm going to get into this in a minute, are annotate our data with LLM. We can do things like extract features so we can filter later. We can do things like rewrite data. We can do things like clean it up using LLMs. If you have a whole bunch of GPUs, LLMs are a great tool to build better LLMs. All of this is, so this is what this VLM thing here is. All of this is done in our data lake, typically using Spark. When I say our data lake is our first class citizen, we love iceberg tables here, right? The first class place these things live is not in a random blob store. It's in a table that makes sense. And we can like talk about how that funnel works a bit more. Eventually, you kind of get down to like a subset of good data for training and more Spark to export this for training, or maybe not. We can get into that in a little while. What kind of happens in this beautiful story I just told is that you tend to get a lot of things, a lot of random feature tables. Where exactly you have like research and production is a bit hazy. And you don't have this like perfect abstraction between like your like formatting, your like raw data and like this beautiful data artifact. But you can kind of like enforce this almost culturally. So a thing we very strongly believe in is that SQL is great. You have some sort of data lake table that is like your single source of truth. You have all your like dev stuff. Eventually you end up with like a table that is like where your data sets live. If you're good about it, you build per researcher schemas. So somebody has like a schema that's their play schema. Eventually these data sets kind of graduate to being in our like, you know, truth tables. You can put stuff behind RESTful services to like hide how the sausage is being made. And you can kind of like have this pipeline. How do we do this? We love Trino. So Trino is this SQL kind of connector. You run SQL, but it can connect to Lance, it can connect to BigQuery, it can connect to Parquet, it can connect to Iceberg, it can connect to really everything. And we have a gigantic Trino cluster. This is, I just saw a question, this is a lakehouse. When I'm talking about this, this is all a lakehouse. And as I said earlier, we absolutely love SQL. So researchers eventually see the light of day, which is like, SQL is really great for things like filtering. And so as I said earlier, we self-host all of this. So this means that we heavily use Spark and Trino. We have custom UDFs, so you can run rando Python. This lets us do prompting, this lets us do embeddings, this lets us do all sorts of different stuff. As an example, we built first-class prompting tools. This is an example Spark function. This is not real, this is like kind of dramatized. But we built stuff to like, you can see that this is reading from a, oh no, whoops. This is reading from a Lakehouse table. That's a Hugging Face Wikipedia data set. It is calling VLM to do a summarization task. All of this is really easily accessible. We've stood up all of the infrastructure to make this really lovely and kind of like a bit seamless. That is not even that hard. This would be, the example here is, this would be taking all of Wikipedia, summarizing each article, and then writing it to this, oh no, it doesn't write it to a table, it just shows the table. But my point is, this isn't like, once you've like stood up this stuff, it's like really not a lot of work. Here's another example. This would be another example of a Spark job, or rather a UDF in Spark. You can write rando Python in UDFs. In this case, we're calling a VLM service. We're taking an image, calling this VLM service, asking it, say like, what is the setting of this image? Getting an answer back from VLM. We're doing this on maybe 100 million images in parallel, using a big Spark job, and then writing it back to our lakehouse. Like I said, everything lives in the lakehouse. It's kind of great. The reason that this is great is because then later we can do things like this. I said we love SQL. We can say, all right, I processed all of these images. I got, you know, brightness and the background height for all of these images. Now I want to run data ablations. Now I want to like play around with data sets to see like, how can I make the best model by like filtering certain aspects of it, or using some of this data set, some of this data set. This is a really easy SQL query to write once you've done that like big filtering job that Spark made really easily. I mentioned earlier that we're responsible for training. We've also written a whole bunch of like a call it training framework that hooks up really nicely to our data lake. So this would be an example of a config. I said we love SQL. There's more SQL here. So what we're doing here is you can see, all right, these are all some rando training params. What I want you to focus on here is that we can also say, this is the data set I want you to train on. It's a SQL statement, and we can do like, oh, some filter this time, another filter next time. All of this lives in the data lake, and so it's not like we have to reprocess this all. This filtering is very quick, so the iteration speed is very, very fast. Once you make this gold data set that has like all of these features that we annotated through things like VLM, your iteration speed is really, really quick. So what else do we use Spark for? We use Spark for all sorts of things. Clustering embeddings. We have at one point run k-means on like the internet. So like this is like a thing that you can do if you set up your compute and environments for like developer productivity, call it. The data.ai team didn't write the clustering job. We instead wrote the tools that like let somebody in a Jupyter notebook cluster the entire internet and then say like, okay, what are the good clusters? We also use it for things like streaming ingestion. A thing that is not so great about Iceberg is that the only thing, and this is not entirely true because there's PyIceberg, but basically you have to live in the JVM if you're going to talk to Iceberg. It's not the most ideal thing, but Spark is in the JVM, and so it talks to Iceberg. So we have a bunch of streaming ingestion jobs that are these like fun shims between our data lake and the rest of the world. We, as I mentioned earlier, do tons of cleaning. This is often done in VLM. This is often asking LLMs what they think of the data. This is doing analytics. We very often want to know what's in our data sets. And so what I mean by this is, what's the average document length? What is, how many documents, like basic analytics, but further analytics kind of on top of the stuff that we've calculated. And like the next two is what I mean by this. We can use things like if we want, I'm blanking on the name, but language detection, Python packages to like ask the question like what language are these things in and get analytics on that. gzip detection or gzip compression is like an example of a metric that we kind of came up with that other people use. The idea there is if you want a really quick way of telling whether a document's any good, gzip it and just ask how much it shrunk by. Totally random documents aren't going to be great, aren't going to compress very well. Documents that are the space key over and over and over again are going to compress great. You can do that filtering that I just talked about in SQL and chop out the stuff you don't want. Find these like thresholds to find where these thresholds are by doing data ablations, and like all sorts of other things. These are just gigantic Spark jobs that we love to run. So how Lance can help us do this? We are super jazzed about Lance. We use it a whole bunch of places. We like are really, there is like kind of a dirty secret here, which is like we have a data lake and we would love it if everything lived in the same format. Lance is a great format for both storing data and training on data. And that's one of the things that really attracted us here. It's a very flexible format. Like point two is like adding rando ad hoc columns. It's great. We don't have to, we have enormous amounts of data. And so us doing like gigantic data migrations is a huge pain. Lance really helps out with that. The fact that it talks to everything, the fact that we can like, we use Ray as our data loader. We use Spark as our like data preparation stuff. Lance can kind of talk to everything, so it's great. And the fact that we can do, the fact that it has this built-in search is really lovely. It powers the search on a website. The fact that we can throw embeddings in there and it kind of works is like a really lovely feature of Lance.
So I'm going to zoom out a little bit and kind of talk about broader things that we're seeing in the market that kind of really rhymes with the themes that Ryan has been talking about. What building LLMs, building multimodal models especially really means for data infrastructure, and what is different this time around for data infrastructure. And the big thing, the big phenomenon that we're noticing is that AI represents a very different set of requirements on what you use as data infrastructure. Sure, a lot of the tools are still the same, right? Spark, you hear about Trino, object stores are still there, data lakes are still there, but this time around, there's tons of things that are different. Imagine you're building an AI model or even just an AI application, right? The most interesting ones, the most valuable ones are built off of not just the plain text, but you have metadata, you have PDF documents, slides, images, audio, video. It runs the gamut. So a lot of that is already in enterprise data today, and AI has really made this data tremendously valuable. So the variety of the data that you have to deal with is a lot more diverse, shall we say, than previously. The volume of that data is also just much bigger, right? Like if you have a table of a bunch of numbers, each number is like 8 bytes, is 4 bytes. But if you have PDFs and images, these are like hundreds of kilobytes, right? Audio and video are like megabytes and even gigabytes. So there are many, many orders of magnitude larger than tabular data. And then number 3 is we're no longer limited to kind of human input, right? A lot of the data that you collect and that you use to either train models or to serve applications especially are actually generated by the model itself. So the rate of data generation, that velocity is now happening much, much faster. So again, sort of old themes of the 3 V's of data infrastructure: variety, volume, and velocity. But this time around, it's just much bigger and much more diverse. So if you look at what we have today, right, there's like traditional data lakes that they're really great for tabular data. So especially if you need to run like BI, data engineering, that then at the end becomes like a BI dashboard or analytics on that same data. This is great, but those kinds of systems, they're not great for search and retrieval. They're not great at dealing with embeddings. They're not great for any of the multimodal data types that you need. And of course, like in the past few years, you've seen a lot of vector databases. That's sort of the new type of database that has come to the fore. But and it's great for vector data, and it supports fast online search. But like most of them don't really integrate with your data lake. So it's sort of this separate thing that you have to copy your embeddings and parts of your data, load it into this other system. So it's more complicated, it's more expensive, and then you have to spend a bunch of your time keeping these systems in sync with each other, right? And of course, the vector database is not great for analytics. It's not great at working with your existing tabular data, or of course the multimodal data itself. It's pretty much only good at that one sort of like nearest neighbor task, and then you have to map it back to your main data lake or your main sort of database in order to move on with the rest of your workflow. So I think neither choice is a really great foundation for what we need for building the next generation of like models and applications like Character is doing. And so this is why we designed Lance format and kind of the LanceDB multimodal lakehouse on top of that. So what we want Lance format to be, it's open source. It's one table for all of your AI data. And by AI data, I mean, of course, the embeddings, but the actual images and the audio signals and the video and the long text, and all the features that you generate from that, right? Maybe you have an image column that then you say, hey, I want to run that through a VLM, generate a bunch of text description, and then add that as a new column. And then I'm gonna summarize. I'm gonna run that through an LLM to generate summary of that text description. And then I'm gonna run the image through a different VLM and extract features that are tags, like, hey, what's the general palette like? What is the mood? Like, how many people are in this image, and add that as yet another column. So this type of like storing all that data together and then making it a single source of truth where you can run all of your different AI workloads on top of that, right? So there's of course the search part, and you can search over the embeddings, you can search over the full text search index. There's SQL to analyze your table. You can run KV fetches in serving. So if it's like a Mongo or kind of Redis like workload, and then of course you can plug that data into your PyTorch data loader to do pre or post training, and all of that starts from the foundation of, hey, all the data lives in your data lake on object storage, so you're enjoying the cost efficiency and the scalability benefits of that. So I think the way we're thinking about it, along with folks like Character and others, is that AI is fundamentally change what we need for data infrastructure. For many AI first companies, what's really important is the ability to iterate really, really quickly and make it so that the research teams don't have to worry as much as possible, that they don't have to worry about the underlying data infrastructure, and really focus on the experimentation logic, the model logic, and the feature logic. And that tooling has to be a joy to use for sort of the non-data and the non-engineers in the research team. And so that is why we designed Lance format, and we hope that you give it a shot, and we hope Lance lives up to its promises in your use case. So I think we're about 5 minutes from the end. So I want to stop here and just say thank you so much for coming to our talk here. And we just want to open it up to any questions that you might have.
Yeah, thanks so much, guys. We have a few in the chat. We'll just get started. So from your experience, and guys, route these as you see fit, right? If you feel like this is more for you or whatever, please just jump in. From your experience, how can you facilitate the cost allocation for projects in cloud for different customers?
So I think this was during my talk, and I'm going to interpret it as customers are researchers, because those are my customers in my job. And so cost is a weird thing at Character, because as I said earlier, we strongly prefer to self-host, because when you buy, say, an H100 instance from Google, you get like 206 or something CPUs along with it, and like 2 terabytes, like just an obscene amount of resources. And so we, to a certain extent, get them for free. So our costs are semi-fixed because they're really determined by how many GPUs we want. How we like split those up amongst researchers is this is a cop-out. Character is small enough and everybody is nice enough that you have a conversation with the person in the next cubicle. I literally did this like on Friday, being like, yo, dude, your Spark jobs are using like a ton of RAM. I can't get my Spark job scheduled. Could we like come to some sort of agreement? So this is to a certain extent a cop-out, but everybody is pretty friendly, and oftentimes it's not malice. So this is a total cop-out, but Character small enough that it's not really the biggest issue. We're all on the same team.
Like, that's a real nice Spark job you have there. It'd be a shame if something happened to it.
Yeah, exactly. Like, I mean, I could kill the Spark job. Like there's like Character, like it's not like you own the Spark job. Like anybody can kill any job they want. It's Kubernetes. But yeah, like everybody is nice. I'll put it that way. So that's a total cop-out, but there isn't, everybody's on the same team, is I guess what I'm saying. It's not a toxic place to work at all.
Excellent.
The next question is really interesting too. Maybe Ryan, I think you probably have lots of interesting things to say about that. What can we do if continuity is lost in the documents that are page by page when trying to search for the document, nothing is returned or the agent hallucinates?
So we don't actually. So this is. I might have less information, less things to say on this. We don't do like giganto rag. So we at our scale, I'll put it this way: we don't do giganto rag. We are very often, and so I'm not really answering that question, but we're more interested in, ideally our training examples are short enough that they fit in a context window. They pretty well have to anyways, because training has a context window. We certainly don't train with like, pulling in on the fly, like tons of weird documents from tons of different places. Like we have fixed training examples. So like to a certain extent, we just live in the context window. Yeah, that's kind of a cop-out. I actually don't, like, you actually, Chang, might have more info on this than me because you deal with customers who are like really interested in this. Whereas we, to a certain extent, just live in the context window of LLMs.
Gotcha. Yeah, makes sense. I think the question is really interesting. It's like there's a couple of pieces to it. So just quickly, I think what we see with some of our customers do with some success is, so number one with continuity is to use contextualized embeddings, where contextualized chunking, where you chunk up the text, but then you have a summary of either the whole document or an entire section where you prepend that context to with the chunk. And then so you embed that whole thing together as one vector. And so when you're searching, you keep that full document context with it. So that can definitely help if you're worried about like a very long document and kind of, like chunk by chunk losing the plot. Number two is searching for like when nothing is returned or the agent hallucinates. I think in terms of nothing is returned, what you want is to have, well, if you're asking for top 10, you're always going to get something, right? The question is whether, maybe the question is, what if you don't get anything relevant? And so I think the answer there is, this is why a lot of our users use the hybrid, maybe like multiple embedding models or multiple ways to chunk up the data and multiple, and then full text search versus versus like the vector search. And then you can combine and re-rank at the end to always make sure something meaningful or increase the chance of something meaningful being returned. Last question is the agent hallucinations. There's tons of ways to deal with that. Typically, it's not something that's done at the retrieval step, but later on, once the first round of answers are spit out from the RAG system, for example, you can have another LLM act as a validator to check the answers, and then you may then have a separate retrieval step where that LLM looks at the answer and maybe some relevant information that you've retrieved and can determine whether it's hallucinating or not.
I just want to add on to that because you jogged my memory. I was answering, when I was doing my cop-out of an answer, I was answering with respect to training data examples, which we intentionally kind of keep short. We have other tricks that we use in production. You can have a very long chat with, and I can't go into tons of detail on exactly how we do that, but you can have a very long chat. So we definitely have to deal with this in production. I was speaking more for training examples. But I mean, the things we do in production are like wildly different than the things that Chang was saying. So.
Awesome. Yes, we got one more question, which is just asking for URL to the demo of Lance. Data storage, if you've got something to check out, guys, our speakers have information on the site that should help you with that.
So we've got a couple of really interesting demos that are going to be released very soon. You can definitely check out our website and check out LanceDB Cloud for some of the tutorials. Some of the bigger scale and more interesting demos are going to be released in a week or so. So follow us on LinkedIn or Twitter, and you'll get it soon.